lesson is on even and odd functions and even the neither functions. First thing I want us to do is I want us to pay attention to what the exponents are on this particular even function. We're going to just look at even functions right now, okay? So here our exponent is 2. As we slide down the page, okay, our exponent is 2. In this problem here, we have 2 exponents here and here. We have an exponent of 4 and another exponent of 2. And on this third problem, and this really should say 3, in our third problem, our exponent is 2. Now, what do you notice about all 3 of these problems? All 3 of these problems have exponents that are even. All the exponents within the problem are even numbers. Okay? This is a definite hint to the fact that we are doing even functions. The next thing I want us to notice is, let's look at the table of values. We're going to look at the table of values for this first problem here, problem number 1. So we know that the exponent is 2. We're going to look at the table of values. Table of values over here is that when I plug in the function y equals x squared, the values here is what I get out. Now, what is it that I want you to notice? What I want you to notice is that when I put in -1, I get +1. But at the same time, when I put in +1, I get +1 out. When I put -2 in the calculator, I get +4. When I calculate +2, I get +4. When I put in -3, I get +9. And when I put +3, I get +9. Now, it looks like we have a pattern going on here. And the pattern sort of looks like if I put in the opposite value for x, over here, opposite values of x, what's happening to my y's? I have a pattern. Now let's see if this pattern holds true for all these even functions. Remember, all the exponents are even. So let's look at this one. Do I still have opposite values of x give me the exact same values of y? It looks like that. So let's look at our third one. See if that happens here also. Yeah, look, opposite values of x, same values of y. Opposite values of x, same value of y. Opposite value of x, same value of y. Oh, I have a pattern. So I definitely have the same thing happening for all 3 of these particular functions. The next thing I want to do is, let's look at what happens with the graph. Now, I did something that many of y'all probably didn't think to do, and that is I went on Desmos.com and I just took a picture of the graph so that I had a really good picture for you to look at. So let's look at what this picture does. Notice that I have a nice curve going on here, and that we've talked about symmetry before, and I have a line of symmetry that is the y-axis. I have a line of symmetry that is the y-axis. Let's see if this holds true for all my 3 pictures. Let's look at this. I have a line of symmetry on this one that is also the y-axis. Nice, a vertical line of symmetry that is the y-axis. Let's look at this last one and see if this also holds true, if we have a pattern going on. So slide that over. Oh, look at that. Even though my picture is slid up the y-axis, I still have symmetry about the y-axis. That means my line of symmetry is the y-axis. So now I have a really good idea that when I have an even function, that I have symmetry. I have symmetry about the y-axis in each case. symmetry about the y-axis of each base. So that's what we're going to learn about is even functions. That's it. I'm done. See you later.